Hi everyone, my name is Fran and I'm a graduate hydraulic modeller here at Jacobs. I joined Jacobs in September 2023, exactly a year ago today actually, so leading this webinar is a very nice way to spend my work anniversary. I was first introduced to the Flood Modeller software when completing my master's course at university, where we built some very basic 1D-2D models. And then over the past year, I've further developed my modelling knowledge and built a range of models for varying purposes, including benchmarking, flood risk assessments, and flood defence scheme development. Today, I'll be discussing how to build a 1D-2D fluvial model within Flood Modeller. More specifically, I'll be covering the benefits of 1D-2D links modelling, and we'll then jump into a live demo in which I'll build a 1D-2D model. As Alistair said, at the end of the session, there will be time for questions, so please feel free to just stick them in the question box as I go along and they will be addressed at the end. So let's start by discussing the benefits of 1D-2D linked modelling. So a 1D river model provides us with in-channel hydraulics. Results from a 1D only fluvial model will give us water level and flow at all of the nodes within a river channel at each time step. While these cross-sections can be extended into the floodplain, which is what we see in this graphic in the top left corner, it's not possible to see flow paths across the floodplain in a 1D only model. And also a 1D only model will apply a single flow rate across the entire cross-section, whether it's extended or not. A 2D model provides us with floodplain hydraulics. So results from a 2D model will give us water levels and flows at each grid cell within a defined active area at each time step. A 2D model is much better at representing the floodplain than a 1D model, as the results can show flow direction. To note, a 2D only model can be used for modelling in-channel flows, but often aren't, because the raster ground survey data in these areas is a lot less available. When you link a 1D, 2D model together, you get the best of both worlds, essentially, as it allows for integrated catchment modelling, providing a more accurate representation of fluvial flooding and therefore a better understanding of flood risk in urban areas. Flood Modeller makes 1D, 2D linked modelling easy with its user-friendly, intuitive interface, as you are about to see in my live demo. So before I jump into the live demo, I'll just talk briefly about the model. The model I'll be using today is the 2012 River Mersey model. This is a 1D only fluvial model, which was initially built back in 2008 by Adam Parks, who's now the Technical Director of Flood Products here at Jacobs. This model is a great example for this webinar, as the modelling was done over 10 years ago, when 1D only modelling was used a lot more as standard. Nowadays, 2D modelling is much more advanced and readily available, and transitioning from a 1D to a 1D 2D is relatively straightforward. So I'll open up Flood Modeller. Can you see my Flood Modeller okay?
Yep, it's loaded.
Okay, perfect. So I have my 1D data file already loaded into Flood Modeller. Here under the 1D river networks, I can turn on some background mapping just to get a better idea of where we are in the world. Under the Home tab and Mapping, Base Map, there's a few different options. I'm just going to use OpenStreetMap. You can also have satellite data in there. As we can see, this is quite a big model. So it's starting upstream in Stockport and flowing down to join the Manchester Ship Canal. In this webinar, I'm going to be focusing on this small upstream area where we have the River Tame, the northern tributary, and the River Goyt, the southern tributary, joining together to form the River Mersey. Now, as this is a 1D only model, the floodplain is currently represented using 1D elements. So using this reservoir unit here, which essentially acts as a bucket to show water leaving the river, and also through extended cross sections. We can see these extended cross sections by dragging our 1D data file into the map viewer. That will then load this down here in our layers panel. We can turn this on and off to see the extended cross sections. So this model has been run previously as 1D only, and we have some results for that which I will look at later. Let's say that the council wanted to develop this area and wanted to enhance this model a little bit by representing some areas of the floodplain in 2D. You would have to remove the 1D floodplain representation and switch this out for 2D representation, which is what we're going to do today. So the first step is removing the 1D elements because we don't want to double count the floodplain. So we'll start off by removing our reservoir unit. In order to remove a unit, you just simply right click and select delete nodes. You can also just use the delete button on your keyboard. When you delete the reservoir unit, you have associated spill units, which also need to be deleted. Again, you just right click and delete node. The river cross section that the spill unit is connected to will reference the spill unit within it. Now you need to remove this reference. If you don't, then the model won't run. You'll get an error back. To do this, you just want to double click into the unit and select edit labels. This little box will pop up and you just want to remove the spill reference like so. You would do that for all of these. I won't do that now. And then once the reservoir unit is removed, you want to truncate your extended cross sections. So for example, we have this cross section here, which as we can see is extended into the floodplain. I will open that up and plot it just to get a better understanding of this. So as we can see, it's extended quite far into the floodplain. Now we want this to cut off here. We only want it to represent our river on the left bank. So in order to do this, I'm going to use a deactivation marker. Now you could just delete this data entirely, but I don't think that is the best way to do these things. You may in the future want access to this data, or you may want to run this model 1D again. So it's much easier to just simply use a deactivation marker instead of deleting these rows entirely. So we'll add our deactivation marker around here, hit OK, and then when we save our network, we can see that the cross section has been truncated and it now only sits on the river. We would do this for all of these. I won't do that now. I don't think it's useful for you to watch me do the same thing over and over. So I will just load in a data file where I've already made these changes. I'll also just delete this to avoid confusion. Okay, if I drag in my DAC file again into the map viewer area, this time we get this pop-up because we have our deactivation markers. Would you like to only display the active area? Yes. So as we can see, our reservoir unit is gone and our cross sections have been truncated. So the 1D changes are now complete. We now need to make some 2D adjustments. So the first thing we're going to do is draw our active area. The active area will essentially tell Flood Modeler what part of the model you want to be represented in 2D. When drawing the active area, you'll be snapping to the truncated cross sections, and I find that when you're zoomed out and the river channel cross sections are turned on, it's quite hard to see. So I'm just going to turn these off. You can do this under the Home tab by unticking 1D River Network, 1D River Nodes, and as you can see, they're now gone. You can also add labels for if you want to see the labels of each cross section. So I'll turn that off for now. I'm also going to turn off the background mapping so it's a little bit less busy. To draw our active area, you just want to go to 2D build and select active area under 2D model. You'll then save your active area. We'll just call this And then you can begin drawing your active area. To draw your active area, you just want to select polygon. Now you will be, as I said, you want to snap to the truncated cross sections, so you need to make sure that snapping is on. This already is for me because I've been using this morning, but usually these would be unticked and you would have to tick that on to allow the active area to snap to the truncated cross sections. You can't see, due to the software we're using, you can't see the snapping for some reason, but when you're in Flood Modeler, you can see a little box, and when you go near the cross section, it allows you to snap. So we just simply draw that and snap to our cross sections. When you get to an area like this where the river is curving slightly, you may want to add another vertex. Once you've finished drawing your shape, you just right click and select Finish Shape, and your active area is complete. Stop editing and save the file. The next step is drawing our link line, and this connects our 1D model to our 2D model. In order to draw a link line, you just want to use the link line generator under 2D build. So if we click, and that'll open this box up. Now we're using our updated Mersey DAT, which is correct. So for this model, you'll need two link lines. So you'll need a link line for the northern tributary and a link line for the southern tributary. I'm just going to draw one of those today. In the example, I'll draw the southern one. So we want to go from this unit here down to this unit here. I know that this is called the Goit 1650, so you just want to find that, and it's going down to Goit 22, which is this unit here. We want to use the active portion, so we don't want to include where we've put our deactivation marker, and we want to trace along a shapefile. We'll use the active area that I've just drawn. You could import elevation data if you wanted to refine this further, but I'm not going to do that today. And the rest I'm going to leave as default. We'll save our link line, give it a name, and hit OK. And just turn off my active area. We can see our link line here. You can make changes to these files. You can change the properties by simply double clicking, and this box will open up. Head to symbology and visual style, and you can change the colour to whatever colour you like. Let's make it pink. So our link line is now much clearer. Same with the active area. You can also make it more transparent, which might be useful. Let's change this to blue and make it a little bit more transparent. That way, if we do have layers under this, we can see them. So we're almost ready to build our 1D-2D model. There's just a couple of bits of data that we need. So I have downloaded some LiDAR data. This is just from the DEFRA website, and this is a 1 meter DTM. So drag that in. I've also downloaded some building data, which will just show where the buildings are in this area. Move these down to the bottom, and I'll turn these off for now. Okay, so my buildings layer, I've made some changes to this. So if you right click and show attributes, I have adjusted this so that the height of 0.2 meters and the method of add will essentially add 0.2 meters to the DTM file that we have where those buildings are. So it's just raising those buildings slightly. You could also get other data, so you could depress roads, etc. But for this example, I just have the buildings. So we now have everything we need to build our 1D-2D model. In order to do this, you just head to Simulations, right-click and select New 2D Simulation. Choose where you want to save that. And you'll see this pop up. If you double click, the simulation window will open up and we can start to fill this in. So I'm going to run my model for 30 hours. So we'll just put a finish time of 30 hours. All of this I'm leaving as standard and I'll come back to linking at the end. Under the Domains tab, this is where you want to be adding your DTM and your buildings layer. If you've loaded those in already, you can simply just drag and drop those into the topography. The order these are in is important. You want the DTM to be the first thing you import and then the buildings to go on top. Essentially, you're piling these things up. So what's top of the list will be at the bottom. We also have our active area that we've drawn. And we can set our grid size to whatever we want. I'll do 2 meters. Our time step, I'm going to do this as tiny time step because this will be run with the GPU solver, which requires a smaller time step. In terms of roughness, today I'm just going to set a universal value of 0.03, but you could refine this further and change the roughness based on what the surface was. Was it a road? Was it grass? Etc. I'm not going to do that today. All of these tabs are remaining the same today. We have our output tab. So this is showing the frequency of the output. This is currently set to 1 hour. I would reduce this down. Maybe I think I did 60 seconds, which is perhaps a little bit too much, but you could reduce it down a little bit. And then this is where we select how we will be running this. So I want to run with the GPU solver, which only works with the TVD solver type. So you just select yes, and that will change to TVD. Heading back to the general tab, we'll sort out our 1D linking. So we will be including a link to 1D river. So if you tick this on, you can see that 1D river links pops up here. We go under this tab and we have our IEF file, so our 1D simulation file, and then we need our link lines. So we'll add our IEF and we'll add our link lines. As I said earlier, we would also have one for the northern tributary, but I haven't drawn that today. You then select save and then hit run. I'm not going to do this now because that will take several minutes to run and we don't want to be sat in silence. So what I'm just going to do is remove this group and load in one that I've made earlier. So this is the exact same, essentially. The only difference is this model has been ran and it's got the additional link line. That's the only difference. To load in our results, you want to hover over the simulation, right-click and select Load 2D Time Series. This box will pop up and you can select what outputs you want. For today, I'm just going to get the depth output. I'm including the variable and the max and hitting OK. And what we'll be able to do is compare the flood extent using this 1D-2D model to that which was produced previously when this was a 1D only model and kind of see how they compare together. Give that a minute just to load in. Okay, so we have our, turn that one off at the moment. This is our maximum depth here. So we can see flooding in this area. I'll turn that off and I'll turn this XMDF on and we can animate this to see when exactly the water starts to come into this area and see the flow paths. To do that, you just want to right click and select animate and you'll get this little pop-up. You can hit play. I'm just going to skip a little bit because I've done this for every 60 seconds, which is a bit unneeded. So we'll just jump to 9.5 hours and focus on this area here. And as you can see, the water is starting to move into the 2D. You can jump this a little bit, make it go a bit faster. But as you can see, there is flooding in this area. And I think it's quite nice to see the flow path, so you can see which areas of the river the water is actually coming out of and which areas perhaps water isn't coming out of. So I'll turn that off. I'll just close my animation window for now. Now I'm going to compare the maximum depth to the maximum depth from the previous run, which was 1D only. So I'll just drag that in. Okay. So as we can see, these differ quite a lot. I would want to understand this a little bit more if this was a real project, but this just shows that they can differ. In this case, the 1D-2D links model causes the flood extent to be notably less. However, that's not always the case. It could be the opposite, could cause flood extents to be much greater, or it could just cause it to be quite similar. In this case, we can see it's reduced it in this area. A lot more thought and insight would need to be put into this, but let's say these results were accepted. This would impact design and flood risk management in these areas, so I think it's quite useful.